con los ad, you're gonna get sick.
Take her vitamins.
Yours in her blanket.
You're like, oh, it's 75 degrees outside. How are you doing? She's like, anyway. Where's my? Oh, she's in Indiana. Nope. Yeah, she went to Purdue. I think she might have moved to Ohio. Yeah, she was like, it's fall, and it was 15 degrees outside.
I wish. It's 90 degrees today.
I live in the cold.
Not here.
Oh.
Okay, so look at this graph. You guys notice the hole? I know, I'm sorry. We all got distracted. The hole and then the filled in point, right? So, question, does this graph meet the extreme value theorem, forever card number 21? Does this graph meet the conditions of the extreme value theorem? Yes or no? Oh, we need to know what those conditions are. So, first of all, H has to be continuous.
Yeah.
Yeah, no jumps, no holes, no vertical asymptotes on a closed interval.
It's not closed.
It's half closed, half open. So does it meet EVT? No. By not meeting EVT, all I know is that there is no guarantee of having an absolute highest and an absolute lowest. But we can just look at the graph like your homework started to see what we do know. If you want, sometimes it is safer to think about what's here before looking at the answer choices. For instance, I see an absolute max. I see absolutely no min because it's not there, right? So we have no absolute min because the hole is there. We do have an absolute max. The absolute max is also a relative max. Why is it a relative?
Because if you...
Yeah, Kathleen.
If you zoomed in, then it would still be there.
If I zoomed in and I went a little bit to the left, a little bit to the right, is it the highest of the region around it? Yeah. But then zoom out. Is it the highest of the region entirely? Yes. For instance, if there, Kathleen, this is the example I used with you yesterday. If there was, theoretically, if there was some way of measuring the best coffee shop in all of America, okay? The best coffee shop. If you went to that town and asked them the best coffee shop in their town, shouldn't they tell you the same one, right? Now, okay, that's like based on opinion. That's a little bit rough. Let's just say there was an actual, like, for sure way to measure it. But either way, locally it's the best. Globally it's the best. Okay, so if you were to zoom in, is it the best? Yeah, on either side. You have to go on either side. It's the highest, and then zoom out. It is the highest, not just a highest, but the highest. Okay, so check it. Does H have a min at -1, -5? It's not even there. It's a hole, right?
Yes.
Does H have an absolute min at 4, 0?
No.
No, because it goes lower.
No.
Does H have a max at 2, 4?
Yeah.
Yes. Does H have no extrema?
No.
I see the max.
Yay.
Therefore,
You got it right.
Number 75 was a bit harder. Why?
Product and chain rule.
Simplifying.
And
Yeah.
simplifying.
Okay, so we have our f of x. What rule did you guys use? I heard you talk about it.
Product and then chain.
Oh my god.
Product and chain?
Yes, ma'am.
The only way to legally derive is with the product rule. So therefore, f prime of x.
That is
Now,
so wrong.
oh dear. We haven't even started yet. We could think about the domain and how f exists everywhere, because for critical numbers, we actually need to think about his existence, but that's all polynomial stuff. He has all real numbers. No stress. Okay, so the derivative, we have second, d first, plus first, d second. Isn't it a u cubed? It's a u cubed, right?
Yeah.
And a u cubed has a derivative of 3u squared times u prime. Now, why am I getting out my green pen? Circling the plus and saying, let's look at these guys in chunks.
Chunky.
This is what she meant by the green.
But anyway, what's in common?
3x minus 1
squared. No.
Squared, right?
X. And then an X.
Squared. And?
An X, yes.
Yeah. I guess we both have an X.
Wow.
But no numbers, right?
No.
What's left?
2.
I have
2.
Oh yeah, a 2 times a 3x minus 1. It's a lot nicer if the 2's in front. So 2 times 3x minus 1. Technically that should be a bracket if you want to be all precise, because those are parentheses. Plus 9. X.
Yes.
Right?
Yep.
And then you're like, oh, x equals 0, x equals 1/3.
Solve.
Guys, it's algebra. It's easy. It's easy, easy, easy. 6 and 9 is 15, x minus 2, right? And what was the point of all this? Well, critical numbers. If the function exists, which it does everywhere, then they are the zeros and the DNEs. Uh-oh. I can set this guy equal to 0, but what are his DNEs?
0, 1/3.
His DNEs.
Oh, there are no DNEs. Sorry.
Oh, there are none because it's a polynomial. So am I even looking at the DNE category?
No.
No, not for this guy. He doesn't have any. Okay.
Blasphemy.
This guy, and that guy, right? Like Moses in this Red Sea. Split it up. Setting equal to 0.
Yes.
Oh.
Dun 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 dun.
Dun, dun.
Yeah, what happened
Dun.
then?
Oh, hello.
I did product rule.
Hello.
Good. Did you do the green rule trick?
I got it.
No.
The green rule trick makes life so much easier because otherwise, wouldn't you have to use like Pascal's triangle to cube a?
bit.
Yeah.
Let's just pull out the common squared one and then not have to worry about it as much. How are we doing? Okay, so what forever words have we done so far in chapter 3? 3a, function analysis.
Number 21.
Number 20 and 21.
Number 20 and 21. 20 is the definition of a critical number. Let a function exist. Ooh, remember we read that one together yesterday? So much better in period 1 than period 6. Period 6 took them like 5 tries. Anyway, they got stuck with the parentheses. They were all just, I don't know. Let a function exist at x equals c, and if f prime of c, the zeros, or DNE, the undefined points, of the derivative, those ones are the critical numbers. I slaughtered it, but that's the idea. Forever number 21, EVT, extreme value theorem, extreme extrema value, y values. If a function f is continuous on a closed interval, a to b, then there is an absolute max and there is an absolute min. But at the bottom of that forever card, don't we also have a how to do it?
Yeah.
With closed intervals, we test f of all the critical numbers and the endpoints. Well, the critical numbers within the endpoints. And then number 2, with partially open, we have to consider function behavior, and the entire chapter is called function behavior analysis. So we got to kind of wait on that one just a little bit. Ooh, there's a party coming. Okay. I did have some other absolute extrema examples with like cosine, trig, ln, there's an ln, but can we just go grade your homework real fast and see how you did before we get to, I had an extra page already. Before we get to rolls and MVT.
Rolls.
Have we not done MVT yet?
Like cinnamon rolls?
Or like belly rolls?
I totally referred to MVT yesterday and you guys should have been like, what? Anyway, that's okay. We're coming to rolls and MVT, but let's grade our homework. Yeah. Okay, 3.1, number 4, 0. Just kidding, what's 0? Negative 2/3. Are you doing a critical number? No, you're asking or you're answering the question, what is the derivative at the point, right? Gross! They took a derivative. Pause. Couldn't you guys have looked at the graph and seen that it was a smooth turn with a horizontal tangent without even doing a derivative? That would have been snazzy. So I guess you could have done all that work, or you could have just been like, hey, smooth turn, 0. At the, whatever was going on. Was it a min? Was it a max?
Wait.
You guys see what I'm talking about? Number 4. Where's the extrema? Right here. What's the derivative? 0. How do I know that? Because it's a smooth turn. Number 6. Definition of derivative. Forget that. Guys, look at number 6. What's occurring at the max?
A.
Sharp point. Good. So just say the derivative does not exist because it's a sharp point. They gave you the graph. I mean, I guess you could think about the definition of derivative not agreeing. Ew. Number 10. What's going on at 2 and 5? 2 is a neither. It's a none of the above. Sadly, it is not relative nor absolute. X equals 5, though, is an absolute max and a relative max. Did you guys get it?
Steve?
Yes.
I think you said all absolute maxes are relative max? But all
No,
relative
no, never said that one. Because absolute extrema can happen at endpoints, and endpoints cannot be relative extrema, according to the AP and this year. BC's book is a little weird. Because there is no other side to look at. So I can't look around because there's a whole side I'm ignoring. Does that make sense? Good. But any absolute max or min inside an interval at a critical number will be both. Okay. Number 12. How'd you guys love that derivative?
I loved it.
Is that nice? Quick power rule, quick factoring. Did you get the plus and minus 2? Hopefully. But there were no DNEs. He was a nice little, just look for the zeros of the derivative. The domain was all real numbers, so no stress. Unit circle. Unit circle. Yep, unit circle, because you had to take the derivative. Secant, tangent. Ooh, wait a minute. Domain. Secant is a trig, and trig has vertical asymptotes, right? Okay, hold on. If we were supposed to think of the existence first, secant is 1 over cosine. Cosine is 0, which means this will not exist. I don't like that. DNEs at the zeros of cosine of x. Where does cosine equal 0? Some of you guys are thinking about this. Some of you guys are thinking about this. What does cosine look like?
Pi over.
Some of you guys are thinking about 1, 2, 3, 3, 2, 1, all over 2 square root of 3 over 3, 1 square root of 3. That's it?
That's right.
I don't know which way your brain works, but all 3 of them should get you to the same answers of when cosine is 0. Cosine is 0 at pi over 2. What? How'd you know that? Well, that's 2 pi, that's 1 pi, and it's halfway in between where it hits the 0 at pi over 2 and 3 pi over 2. Or cosine is 0 when the x is 0, which happens at pi over 2 and 3 pi over 2. Or cosine is 0, wait, so ka toa. Oh, at pi over 2. However you think about it. Cosine 0, cosine 0, cosine is 0. So, pi over 2. Oh, it's not there, right? Because negative pi over 6 is a that one, and a pi over 3 is a that one. So it's 90 degrees they're going through, but are they ever hitting the vertical asymptotes of cosine? No. Nope. Okay, so then domain is good. He exists everywhere here. He has discontinuities, but they're outside, so it's okay. Secant is continuous on this closed interval. Let's go looking for, is this absolute extrema? Look at your directions. Are these absolute extrema that we're looking for? Guys,
yes.
Hold on. Thank you.
Yes.
How did it take us that long? Number 36, just look above at your directions. Do I have to look super close and start taking off points again? Make me do that. Okay. So critical numbers. We already figured out where secant doesn't exist. That's at pi over 2, 3 pi over 2. We should know where tangent doesn't exist because of his basic graph. He has vertical asymptotes at pi over 2 and negative pi over 2. Once again, not there. So DNEs, are there DNEs in the interval? No, they're outside. These guys only have issues outside this interval. Okay, cool. So therefore, zeros. Ooh, when does secant equal 0? Is that possible?
Yeah.
How would you solve this? Secant equals 0. Because, right, set each guy equal to 0. Does it? This just becomes 0 equals 1, which never could possibly happen? Does that make sense? So does secant have zeros? Nope, well that doesn't help. I'm not crossing him away from the derivative. He is a part of the derivative, but he doesn't have zeros, and his DNEs aren't in there, so he's not helpful. Tangents, DNEs aren't in here, but, ooh, does tangent have a 0? Yes. Think about the tangent graph. He hits the axis at 0. Oh, sweet. So I have a critical number at 0, and I have my endpoints. And remember, you can always think of, oh, tangent, when are you 0? Ha, there he is. Or tangent, when are you 0? Well, you are sine over cosine. And so I could set that equal to 0. Cosine pops up, 0. Sine equals 0 at 0. I need to stop covering the unit circle, but guys, do you need to know your unit circle somehow?
Yes.
Yes. Okay, so what'd they do? With the critical numbers and the endpoints? What's our forever card say to do? To find absolute extrema? This one says evaluate f at, and this one just says plug it in, plug it in, plug it into who or what? The derivative? The original function. I'm just talking to myself. Okay, let's just go back. So anyway, plugging in, you end up with That guy's decimal is unit circle flipped upside down. That guy's unit circle flipped upside down. And then plug it in, unit circle flipped upside down. Because secant is 1 over cosine. What's the lowest? 1. What's the highest? 2. That guy was in the middle, forget him. So we have our absolute min of 1 at 0, absolute max of 2 at pi over 3. Number 48. You guys can check out your, sorry, let me get rid of all this stuff. Your minima, your maximum, your minimum, your maximum, and your maximum. Ew, what's going on with that guy? Why are there so many A, B, C, Ds? What's number 48, guys? They gave you different intervals to consider and say, okay, think about this guy on him, on him, on him, and on him. How on earth did they expect you to do 1, 2, 3, 4 different absolute extrema tests? And they didn't even show any work. They didn't even find a derivative. Are we supposed to know what this guy looks like? Because look, these answers kind of look like they were looking at a graph and doing it kind of like, hey, how much work did you guys show on the first multiple choice today?
Not much.
Not much. Why? Because you were looking at a graph. It was easier, right? Number 75. Yeah, it had some work, right? So, who is 4 minus x squared, and why are we supposed to know what he looks like? It's a basic graph we should probably add into our forever card. Because if you were to solve for y, a circle, which hopefully we all know, could look like this. It's a semicircle. Does that make life easier?
Yeah.
You didn't have to take a derivative. You didn't have to think about zeros or d and e's. You just had to think about a semicircle. And in context of the problem, you start to think about a semicircle with either A, closed endpoints, B, half closed, half open, C, open, open, D, ew. That's weird. It's like starting later. Anyway, would that have made life a little bit easier?
Yes.
So it's like, hey, absolute min is here. It's 0. Absolute max is there. It's 2. Well, at 0, but 2. So anyway, each of these are, if you were to actually draw the graph, little semicircles with the 0 or the y-axis going right through the vertex or the edge of the circle. There we go. And then you have your 1 and your 2 and your 2 and your 2 and your 2. And you have your vertex at 0, 2. Anyway, guys, that would have made life so much easier. P.S. The AP loves, hey, remember that special AP highlighter or colored pen? This is a great one to mark out. The AP loves to give you a half circle. And you could spend a lot of time doing all the calculus to it, or just look at the semicircle and be like, oh, life is easier. And then that takes us down to number 62. And number 62 is another concept-y one, right? How do you see it? Love that one. Did that remind you at all of the one that we did in, let me get rid of that, the one we did in class with the graph and the sharp points and the curves?
Yeah.
It should have reminded you. Except this time they put a hole. Just one hole? Yeah, just one hole. Sorry, there's a bit of a glare. So, sorry, let me go back and let you guys check. A is an absolute min, B is a relative max, C is neither. D is a relative min, relative max, relative min. There is no absolute max because it's at the hole. Is that right? Oh yeah, the absolute max is at the hole because it technically goes higher than this relative one. And then none of them are both relative and absolute because all of the in-betweens are either lower than or higher than the endpoints. So sorry, one more second.
Oh, there's absolute.
Sorry, did I say no absolutes at all? I meant no absolute max.
Nice.
And I said that no points are both absolute
Yes.
and relative. Just leave that in there.
Actually.
I think we made it through homework evens, did we?
Yep.
Can we pass out these notes really fast before I forget? Keep 11, Tyree, and we came up with something else. Thank you. Okay, guys. Let's go talk about this guy called mean value theorem and Rolle's theorem. I know you don't want to hear this, but we've been talking about the AP ever since this class started, right?
Naturally.
And if you want, if it's more applicable, let's talk about the next test. We just took one. Some of you, we still need to take that one. Okay. The next test, chapter 3A. Then we have chapter 3B, and then Christmas break. Oh wait, a final exam. Then Christmas break. Oh, don't worry, we have Thanksgiving break first, and we have our 3-day weekend right now. Okay.
Yeah.
Just hang in there. This topic, today's topic, will be in so many places on the AP. So many places. It's going to show up in really concept-y multiple choice with like a, hey, 1 is 2, or 1 is true, 1 and 2 are true, 1 and 2 and 3 are true, 2 and 3 are true. If they give you weird little like conditions, they could use the word differentiable, they could use the word continuous, they could use the word guarantee, they could use the word must exist. It'll show up in concept-y multiple choice. It'll show up in do calculus and solve multiple choice. Oh, concept-y and solving? It'll show up in FRQs whenever you see the word must there exist or guaranteed. And there is one mistake that even those kids that have the card memorized, word for word, backwards and forwards and upside down, still make. Still make. Technically, in the past, we've made this 2 forever cards. This year, we're making it just 1. I think last year we just made it 1 also. Because technically, even though there are 2 sides, there are 2 different theorems. Even the book calls it Rolle's and mean value theorems. Technically, as far as application, we really just think of 1. Even though the book even says, like, think of them as 2. In my notes, I say think of them as 2. There really is just 1. So let me highlight the most important one for you to know. That's not really meant to be, but that's okay. Because this one is the general theorem, and this one is a specific case. Rolle's is a specific case. It's actually named after a guy. There was a guy named, you might say his name Rollies, actually.
Roll Tide.
Roll Tide.
And I don't know his first name. He's one of those guys who just know him by his last name, like Euclid. Anyway.
You don't get it? I get it.
I would say Galileo, but Galilei, we kind of know that.
The Roll Tide.
But Rolle's is a specific case, and mean value theorem is a general case. Wait, mean value. We have intermediate value theorem, talking about the in-between y's. We have extreme value theorem, talking about the highest and lowest y's. And now we have mean value theorem, talking about the average rates? Aw, bummer. The other 2 theorems are talking about y values, function values. This one is talking about rates, aka derivatives. So if you guys notice down here, at some point in the closed interval, the instantaneous rate equals the average rate. We're talking about the average rate. That's where the name comes from, mean value. Mean, average. Mean, median, mode, remember those?
Nope.
Barely.
But they were a thing once upon a time.
In the summer,
Yeah, probably a little bit. I know we talked about average rate, FB minus FB.
You have
I
to go for
remember-
SAT and
yeah, that's why, because I was thinking for the SAT in the summer, that's what I think.
Both of them say if f is continuous on the closed interval, aka endpoint to endpoint, no holes, no vertical asymptotes, including the endpoints. We saw last chapter, or last section I should say, If there are holes at the endpoints, some stuff could happen, so we have to be careful with that. So continuous on the closed, from endpoint to endpoint, differentiable on the open. Everywhere in between has to be smooth. Continuous on the closed, endpoint to endpoint, differentiable on the open. Everything has to be smooth. So no d&e's and derivatives. This guy says something extra. F of A has to equal F of B. If so, the instantaneous rate is going to be 0. But mean value theorem says there is a number x equals c such that the instantaneous equals the average. F prime of c equals F of b minus F of a all over b minus a. So technically, when F of a equals F of b, F prime of c will equal F of b minus F of b all over b minus a. That's going to be 0. That is rolls. So instead of writing out 2 completely separate forever cards, we're going to make it 1, and we're going to say, you know what, that guy is this guy with 1 extra little piece, and the extra little piece says F of a equals F of b. And if that's true, then plugging into the average rate formula, well, instead of F of b minus F of a, it'll be F of b minus F of b. That's 0. That's 0. And that is our this weekend. Please catch up on your forever cards. Forever number 22. Forever 21 was yesterday. Forever 22 is today.
Oh, that's going to be on our sweatshirt. Forever 21. Describe what it is.
I don't know about that one, Kyle.
It's something. I'm sure no one had thought about it.
That's true. It's never been on a sweatshirt before.
All the past people would know that.
and Adam are going to work together.
Andrea's like, thank you, but no.
I'm going to give my ideas. I'm an American. I have freedom of speech.
No one said that.
I knew Kyle was going to say
He's just
that.
throwing, hey, that's what Kathleen wanted though. She was like, I want to hear what people have as ideas. Because inside jokes are little things. BC is really hoping to do something about the killing of animals. Because no one's done that one yet. They've thought about it.
Oh.
Bad math kills.
Can we put more on our sweater?
Oh,
Like save the, save the turtles, but save the bunnies or
no one's
something.
done the rules. Look.
What and she just said BC.
Did you hear what she?
Yeah.
It's okay, we do it first.
Just kidding.
Hey, whoever designs it first, you can claim it. Or you can both equal at
Yeah,
that.
that Richmond didn't approve it.
Hey guys, can I give you a picture example of what's going on? A picture example is any curve, no matter what, as long as there are smooth turns and it's continuous, that's not a hole, it's an O or a B or something. Continuous from endpoint to endpoint and smooth turns only, whatever that average rate is. If you were to figure out the change in time, even if your speeds are varying in between, the average rate you had to hit somewhere. You had to hit that actual, the tangent line is going to be parallel to the secant line at least once, if not more. So here's how, because some of you, a 3-day weekend, you would love to get ahead on homework. Get your 2 forever cards written down, and then here's how you solve. You take the derivative and you set the instantaneous rate, or the derivative, at x equals c equal to the average rate on a to b. So equation equals equation, and then you solve for any c's within but not including a to b. That's literally what you do for NPT, the entire chapter or the entire section long. You find the derivative, like critical numbers, you find the derivative, but instead of setting that equal to like a 0 or a D&E, you're setting it equal to, okay, you're going to have to find the average, which we've talked about before, f of b minus f of a over b minus a. So equation equals equation, or probably value, and then you have to solve for c. The place where everybody makes a mistake is this one. They forget to, they find this side and say, I'm done. They don't set the derivative equal to it and solve. We'll see examples on Monday, that's why this homework is, or on Tuesday, because it's a 3-day weekend, which is why this homework is not due until next Wednesday. But man, guys, if nothing else, do what we call a derivative worksheet. And pull up section 3.2 and do every single derivative of any problem that says find or solve MVT, and then you'll have your derivatives all done for homework when you do it. Thank you guys for all your